What if I told you that one simple equation has been quietly shaping the world around you for over 2,000 years? Not in theory, not in some distant classroom, but in the roads you drive on, the houses you live in, the stadiums you watch games in, and even the phone in your hand. 3 letters, 2 squares. One relationship that refuses to break, the Pythagorean Theorem. Most of us first heard it in school as something to memorize, a squared plus b equals c. Maybe you wrote it down, passed the test, and moved on. But here's what nobody really explained. This formula isn't just math. It's proof that the universe has structure. And once you see it, you start noticing it everywhere. Let's break it down simply. Imagine a right triangle. One corner is a perfect 90 degrees. The 2 shorter sides form that right angle. The longest side, across from it, is called the hypotenuse. The theorem says that if you square the length of the 2 shorter sides and add them together, you'll always get the square of the longest side. Always, no exceptions. That consistency is what makes it powerful. But here's where it gets interesting. This idea existed long before it had a name. Ancient Babylonian tablets, dating back nearly 4,000 years, show number patterns that follow this exact relationship. Builders were using it before it was ever written as a formula. Later, Greek mathematicians formalized it into geometric proof. The principle survived because it worked across cultures, across centuries. Now think about construction. If a builder wants to make sure a corner of a foundation is perfectly square, they don't just eyeball it. They measure 3 feet along one wall, 4 feet along the other, and check that the diagonal measures 5 feet. If it does, they know the angle is exactly 90 degrees. That's the theorem in action. It's the reason buildings stand straight and bridges align correctly. Surveyors use it when measuring land, carpenters use it when framing houses. Engineers rely on it when designing highways and aircraft components. Even computer graphics use it to calculate distances between points on a screen. Every time something needs precision, that relationship between the sides of a right triangle shows up quietly in the background. And here's something many people never realize. The theorem isn't magic. It's geometry. Imagine drawing 4 identical right triangles inside a square. Rearrange them carefully and a smaller square appears in the center. Calculate the area 2 different ways, and the equation reveals itself naturally. It's not about memorizing symbols, it's about seeing how shapes fit together. What makes this theorem fascinating isn't just its age, it's its reliability. In a world that changes constantly, this relationship never does. If the triangle has a right angle, the equation holds. Whether the triangle is the size of a notebook or the size of a football field, the math remains consistent. That kind of stability is rare. But beyond construction and engineering, there's a bigger lesson here. The Pythagorean theorem teaches us something about understanding versus memorizing. Many of us were taught to repeat the formula, fewer of us were shown why it works. And when you understand why something works, you don't just remember it, you trust it. So the next time you see a roofline, a staircase, or even the corner of a room, remember this. Hidden inside that shape is a relationship discovered thousands of years ago. A simple equation connecting 3 sides in perfect balance. The Pythagorean theorem isn't just a math rule from school. It's a foundation, quiet, consistent, enduring, and once you truly understand it, you start to see the world not as random lines and angles, but as a structure built on relationships that always add up.